Have you ever stopped to wonder why you can pretty much always add an item to your Amazon cart, even during the absolute chaos of Black Friday? Well, we're about to pull back the curtain on the 2007 paper that made all of that possible. It's called Dynamo, and it wasn't just some secret weapon for Amazon. It turned out to be a blueprint that completely rewired how the entire internet deals with massive, massive scale.
Okay, this single sentence right here. This is the key to understanding everything else we're going to talk about. See, back in the mid-2000s, Amazon wasn't just a big website. It was this sprawling digital city built on tens of thousands of servers. And when you're that big, things are always breaking. Hard drives die, networks get flaky, whole data centers can just go offline. So the challenge wasn't to stop failure from happening. That's impossible. It was to build a system that just treated failure as, business as usual.
So, let's really frame the problem here. For a company like Amazon, downtime isn't just some technical glitch. No, it's a direct shot to the wallet, and maybe even worse, it erodes the trust you have with your customers.
And this quote from the paper itself really lays out the pressure they were under. For something like the shopping cart, every single second it's unavailable means thousands of frustrated people and just lost money. The stakes really couldn't have been any higher.
Just take a look at this diagram. It gives you a sense of the crazy complexity they were juggling. A single page load on Amazon.com could trigger calls to over 150 different services, and each one needed to get its own data. This whole complicated dance had to happen in milliseconds from millions of people at the same time. The traditional databases they had back then, which were built for perfect order and consistency, they just weren't cut out for this kind of controlled chaos.
So here's the fundamental mismatch. Your typical database, the kind with those strict ACID guarantees, prioritizes being correct above all else. They would literally rather go offline and become totally unavailable than risk giving you slightly wrong data. But think about it. For a shopping cart, being unavailable is the worst possible answer you can give a customer. Amazon realized they needed a whole new way of thinking.
And that leads us to Dynamo. This thing wasn't just a new piece of software. It was a radical new philosophy for how to store data. It was a system designed from the ground up to put one thing above absolutely everything else: being available.
So this lays out the big trade-off they had to make. On one side, you've got the old world, strong consistency. The data is always perfect, but the system is brittle. And on the other side, you've got Dynamo's choice, high availability. Dynamo is what's called an always writable data store. That means it will almost never, ever reject your request to add data, even if that creates a little bit of temporary weirdness down the line.
So to build a system that expects failure, they followed these core principles. It had to scale one machine at a time, nice and easy. Every server, or node, had to have the exact same job. That way there's no single special server that can bring everything down. It was decentralized, with nodes talking to each other instead of a central master. And it had to work on all kinds of hardware, because in a fleet that big, you've got a mix of everything.
Okay, so that's the philosophy. But how did they actually pull it off? Let's dive into the nuts and bolts that let Dynamo just shrug off the constant everyday failures of a massive system.
All right, the first secret ingredient is this really clever idea called consistent hashing. Just picture a giant circle. Now, you place your servers at different points on this circle. When a new piece of data comes in, like your shopping cart, you turn its key into a position on that same circle. Then, you just walk clockwise around the ring until you hit the first server. Boom, that's its home. It's a brilliantly simple way to spread data out, and it means if you add or remove a server, it only really affects its immediate neighbors. But of course, you never store important data in just one spot. That's just asking for trouble. So Dynamo copies every piece of data onto n different servers. Usually, n is 3. So you have the first server and its next two buddies on the ring. That little group is called the preference list, and it makes sure that if one server goes down, your data is still safe and sound in other places.
Okay, now this is where it gets really smart. To manage all these copies, Dynamo uses a quorum system. Think of it like a little election for your data. You've got n total copies. To save something new, you need W nodes for write to confirm they got it. To read it back, you need to hear from R nodes for read. A super common setup is n equals 3, and R and W both equal 2. Because R plus W is more than n, the math just works out so that the group you read from is guaranteed to overlap with the group you wrote to. It's how you get consistency without locking everything down.
Right, but what if one of those preferred servers is down when you're trying to save your data? A traditional system would just fail the whole operation, not Dynamo. It uses what's called a sloppy quorum. It just finds the next healthy server on the ring and gives it the data with a little note, a hint, that says, hey, this actually belongs to server A. When A comes back online, give this back to him. This is the real secret sauce to being always writable.
So, all of this amazing availability, it comes with a price tag. By never saying no to a write and by being so tolerant to failures, Dynamo gives up on that perfect, immediate consistency. Instead, it embraces something called eventual consistency.
And this is the million-dollar question, right? If you and I both try to add an item to the same shopping cart at the same time, and maybe our requests go to different servers because of some network hiccup, what happens? How does the system figure out what the true shopping cart is when there are two conflicting updates?
The answer is this really cool mechanism called vector clocks. You can think of it like a detailed family tree for every single piece of data. So let's walk through this diagram. A write creates version D1. Then another write updates it to D2. But now look, two different servers both update D2 at roughly the same time. This creates a fork in the road, a split in the timeline, resulting in two conflicting versions, D3 and D4. The vector clock lets Dynamo look at their histories and see that they're siblings, not parent and child. Instead of trying to guess which one is right, Dynamo just hands both versions back to the shopping cart application, which has the smarts to merge them back into one new happy version, D5.
So what does this actually feel like for you, the user? Well, it means that your add to cart click is never, ever lost. But it might mean that an item you just deleted could mysteriously pop back into your cart for a moment. That happens if the system has to merge an old version of your cart with your new delete action. It's a tiny bit of weirdness, and it's the small price you pay for a system that never fails your request.
And here's the reality check. Does this kind of conflict happen all the time? Not even close. The paper revealed that in a 24-hour test on the live shopping cart service, 99.94% of all requests saw only one single, non-conflicting version of the data. So yeah, conflicts are a thing, but they are incredibly rare in practice.
Okay, let's zoom out for a second. The ideas in this paper didn't just stay locked up inside Amazon. They spilled out into the world and created this huge tidal wave of change across the entire tech industry.
You know, one of Dynamo's most important legacies was its obsessive focus on performance at the 99.9th percentile. See, it's not good enough for the average customer to have a fast experience. When you're at Amazon scale, even 0.1% of your users is still tens of thousands of people. So Dynamo was engineered from the start to make sure that almost everyone had a fast, snappy experience.
And they were absolutely obsessed with shaving off every last millisecond. This chart shows how one really clever tweak, just moving some of the coordination work from the server over to the client, slashed that worst-case latency in half. It's a perfect example of how they fine-tuned the whole system for a better, more consistent experience for you. When you get right down to it, Dynamo's influence is just everywhere today. It made eventual consistency a respectable and powerful engineering choice. It helped kick off the entire NoSQL or not only SQL movement, which gave us databases like Cassandra and Riak. More than anything, it proved that for a huge class of internet applications, being available all the time was way more valuable than being perfectly consistent all the time. The DNA of this paper is in the cloud services we all use every single day. The reason your Netflix stream almost never buffers or your social media feed is always right there when you open the app, a lot of that resilience comes directly from the ideas pioneered right here.
And that kind of leaves us with a final question to chew on. As you go about your digital life, think about it. Where do you need that perfect, bank-level, can't-be-wrong consistency? And where would you much rather have a system that is always on, ready for you, even if it's a little bit weird sometimes? The trade-offs that Dynamo brought to light are now just a fundamental part of the world we live in online.